In this lecture, we're going to be discussing 9.5 that talks about solving trigonometric equations. Now, there are quite a bit of equations that we can come across, so that's why we're going to do quite a bit of examples to kind of give some insight on how to solve them. So for instance, here we're asked to find all possible exact solutions for the equation cosine of theta equals 1/2. Now, hopefully by now we know what angles give us, when we take the cosine of that angle, we get 1/2. So if we have that cosine of theta equals 1/2, well, that means theta must be either pi over 3, since it's positive 1/2, or theta can also be 5 pi over 3. Now, this is if theta is between 0 and 360, right? Or you can say 2 pi. So these are your answers that are in, this means in the interval 0 to 2 pi. But they said we want to find all possible. So we're not restricted to just 0 to 2 pi. So really, any increments of 2 pi added to these would give us our solution. So for instance, that means theta is going to be equal to pi over 3 plus 2 pi, because we're going to take a revolution, and that will give us the same location of pi over 3. So all angles that have that terminal side of pi over 3 will be a solution here. And really, it's plus or minus, and it doesn't have to be just 2 pi. It can be 2k pi, where k is an integer. So it could be 2 pi, which is when k is 1, and it could be 2 times 2 pi. You could do 2 intervals or 2 rotations or 3 rotations. So here, k is an integer. And the same for if it's 5 pi over 3, you would do plus or minus 2k pi. And these will give you your solutions for theta. Okay. Let's look at another example. Now here, we're asked to find, and so this is a type of linear trigonometric equation. So we're asked to solve this equation. And so when we're solving linear equations, we think to ourselves and we say, well, what do we do? Well, when we're solving linear equations or any equation, what we try to do is to isolate, right, what we're solving for. And so in other words, we're going to put our constants on one side and our non-constants on the other side. So for instance, here we have 2 cosine theta minus 3 is equal to -5. So this is a constant, so I'm going to add 3 to both sides. And so if I add 3, I'll get 2 cosine theta equals -2. But then remember, in this instance here, I'm trying to figure out what is theta. So I'm going to get rid of this 2 as well by dividing both sides by 2. So then I have that cosine of theta is -1. So now I would think, what angle, when I take cosine of that angle, I get -1. If you think about the unit circle, the only place that cosine is -1 is on this side, where we have -1, 0, and this is when theta is pi. So that means my theta is pi. And so notice that we're restricted to one rotation, or theta must be between 0 and 2 pi. So this is my only solution here. Theta must be pi. So when we're solving these type of equations, it's very important that we know where theta lies. Okay, so now let's look at this problem where we're finding cosecant of theta. And here we're told, now notice that theta is where? It's between 0 and 4 pi. So in this instance, we're doing 2 revolutions, okay? So let's first look at finding theta. So of course, we don't have CSC on our calculator or on our unit circle where we can just plug in and figure out what theta is. But we know that CSC, or cosecant of theta, is the same thing as 1 over what? Sine of theta. And that's going to be -2. And so what I could do is solve for sine theta. We could do cross multiplication, putting this over 1. So we know that -2 times sine theta is equal to 1 times 1. And then I would divide both sides by -2 like we've done before. So this means that sine of theta is -1/2. Now, if sine of theta is -1/2 and we're in 2 rotations, so we have quite a bit of possibilities. So the first one, we know that theta, if we're looking at theta when we take sine of it, we get -1/2. Well, the first one, that's going to be negative. It's going to be 7 pi over 6, right? Because if sine, meaning your y value, is negative, we're going to be in the third quadrant, right? Starting in the third quadrant, then we have 11 pi over 6. That's in your first rotation. But then if you add 2 pi to each of these, then you'll have 19 pi over 6 and 23 pi over 6. And we can look at it. So for instance, you have 7 pi over 6. Let's say we're adding 2 pi to that. Of course, we need to have 6 as our denominator for both. So we multiply the numerator and denominator by 6. And so this becomes 7 pi over 6 plus 12 pi over 6. And so that's how we got 19 pi. So by adding another rotation, since it's a 2 rotations, okay? And the same thing if you were to add 2 pi to 11 pi over 6. So these are your possible answers for theta. All right. All right, so now here we want to solve exactly tan theta minus 2 equals 1. Okay, so if any of us know anything about the unit circle, one thing we should remember, the only place on the unit circle that gives us tan of any theta equals 1 is that 45 degree angle, which is pi over 4, right? Also, not only the 45, but the one in the third quadrant as well, because you have a negative over a negative. I think it's 225. Okay, so now in this instance, that means that, so if the only angle that we're looking at here is going to be, well, the first angle that we're going to look at is pi over 4, that 45 degree angle. So that means theta, this whole thing here, minus pi over 2 must be 45 degrees. Well, we're in radians, so that must be pi over 4. So if we're solving for what is the theta that if I plug it in and I subtract pi over 2 from it, I'll get pi over 4. Well, I'll add pi over 2 to both sides. So I get that theta equals, is that 3 pi over 4? Okay. And so here, the first theta is going to be 3 pi over 4, right? But we're not only looking for one theta. We're looking for theta that's where? Between 0 and 2 pi, okay? And so the first one is, of course, pi over 4, 3 pi over 4. Now we will have another theta, that will give us the same solution. And so if we add pi, okay, or you could just say plus or minus k pi. But note that if, just to be mindful, if you say plus or minus k pi, just remember that we're in one rotation, okay? So that's why we're doing k pi, not 2 pi. But if we're in one rotation, we cannot exceed that, okay? So now if you add pi, where k is 1, to this, then you'll get, really, this is going to be 4/4. So we have 3 pi over 4 plus 4 pi over 4. That's going to give us 7 pi over 4. So we have two thetas. We have, that's in this interval. So that means theta is going to be equal to 3 pi over 4 and 7 pi over 4. Okay. All right. So those are two thetas that satisfy this here. Now here we are looking to use a calculator to solve this problem. So now if you are using a calculator, I'm hoping that you guys have the required calculator. Let me pull up Desmo. So you should be able to utilize the sine inverse or secant inverse function. So if we have secant of theta equals -4, well, we can take the inverse of, this means we need to find theta. And so that means we should take the inverse. So sometimes some of our calculators do not have the inverse though, right? So when I'm saying inverse, I'm talking about, you should see something like this on your calculator. That's what I'm referring to when I say inverse. But if the inverse is not there, you can utilize the fact that secant of theta is the same thing as 1 over cosine theta, right? So basically we're saying that 1 over cosine theta is equal to -4. Of course, we can do cross multiplication again. So we have that -4 cosine theta is equal to 1. So that means cosine theta is -1/4. And so here we're thinking, well, what value of theta gives me -1/4? Well, if secant inverse is not on your calculator, then you should have cosine inverse. So you should have the function cosine inverse on your calculator. And so let me see if Google will give me this. So cosine inverse of -1/4. And of course, you want to make sure you are getting your answer in radians, okay? We should have here we go, cosine inverse of negative. Now, I don't know what calculator this is, but at any rate, here we have the, what do you call it? The radian value. And so the radian value here you'll see is 1.823, blah, blah, blah. And they already told us the plus 2k pi. So yeah, so we see that, oops, there we go. Cosine inverse of theta, actually not inverse of theta, of 1/4, -1/4. That's 1.8235. Make sure, depending on your mode for your calculator, be sure that it's in the correct mode. And so in this instance, there was no restriction on where theta should be. So that means we're going to do a revolution. So for every revolution where k is an integer, this solution holds. So this will be our answer. So that means that theta equals 1.8235 plus 2k pi. All right. Okay, so now all of the problems we're looking at thus far involve linear expressions. So now let's look at some problems that involve quadratic expressions. So for instance, here we're asked to solve cosine squared theta plus 3 cosine theta minus 1 equals 0. What we can do here, we can let cosine theta be equal to x. Now, if cosine theta is x, that means our problem becomes x squared plus 3x minus 1 equals 0. And so it breaks down to a regular quadratic. I don't think we can find two numbers to multiply to give us -1 and add to give us 3. So we can utilize the quadratic formula, noting that a equals 1, b equals 3, c equals -1. So recall, this is our formula. Plugging in, we'll have -3 plus or minus the square root of 3 squared minus 4 times a times c. And this will be all over 2 times 1. Okay, and so this becomes what? -3 plus or minus the square root of 9 minus becomes a positive, so plus 4 divided by 2. So this is -3 plus or minus square root of 13 divided by 2. So what does this mean? This means, though, recall that x is cosine, and this is if we're finding x, so this means that cosine of theta is equal to this, -3 plus or minus, so this was x, but we're plugging back in this x here, right? So because remember, we let x be cosine theta. So this would be plus or minus 13 square root of 13 over 2. Okay, so then, of course, this means we have to solve for theta. And so to solve for theta, we will plug in. So theta is going to be cosine inverse, right, of -3 plus root 13 over 2, or -3 minus root 13 over 2. Okay, so now if you plug in this value, -3, cosine inverse of -3 plus root 13 over 2, well, we will get 1, theta equals 1.26. Okay, now for the second one, if you plug this in, you'll get an error. Okay, because this is not in our range that we're looking for. So this is not a solution. So this is your only solution. Theta is 1.26. Okay, well, this is the only solution from this problem here. So notice again that theta is between 0 and 2 pi. You usually can gauge it and see that there's two solutions when you do your rotation, right? But in this instance, we know that, well, cosine, we're only looking at the negative portion of this, and then this becomes So this is going to be a negative value. Give me 1 second. Plug in this computer. All right, so the terminal side of this angle lies in quadrant 1, okay? And since cosine is always positive, it's also positive in quadrant 4, right? So it's also positive in quadrant 4 because if you think about it, root 13 is going to be between root 16, which is 4, and root 9. So it's going to be between 3 and 4. So this number at the top is going to be positive. So this whole thing inside here is going to be a positive value. So that means theta is positive, cosine is positive in quadrant 1 and 4. So the angle in quadrant 1 is 1.26. To find the angle in quadrant 4, we could just do theta. We could just do 2 pi minus this 1.26. And so this is going to be roughly 5.02. Of course, you can do 2 times pi and then subtract, and then you'll get your answer. So we have these two answers for a solution, okay? All right, so next let's look at another example. Here we're asked to solve the equation exactly. 2 sine squared theta minus 5 sine theta plus 3 equals 0. So again, notice that this is a quadratic form. If I let sine theta be equal to x, then this becomes 2x squared, right? Minus 5x plus 3 equals 0. So we're looking for two numbers that multiplies to give us 6 and adds to give us negative 5. Well, that's going to be 6 and, well, negative 6x. Well, no. It's going to be 2 and 3, actually. Okay. It's going to be negative 2x minus 3x. There we go. So I'm splitting them up from this part here. So factor by grouping. So this becomes x minus 1 minus 3, x minus 1. So then this means that 2x minus 3 times x minus 1 equals 0. So then 2x, but let's rewrite this. Really, sine x or sine theta equals x. If I rewrite this, it becomes 2 times sine theta minus 3 times sine theta minus 1 equals 0. So that's really what we have. So if 2 times sine theta minus 3 equals 0, then that means 2 sine theta equals 3 and sine theta equals 3/2. Of course, if I plug this sine inverse theta, sine inverse of 3/2, I'll get theta. So that means we can plug this in our calculator to get theta. And then we can do also sine theta minus 1 equals 0. So that means sine theta equals 1. Okay. Or if you want to solve for theta, that's going to be sine inverse of 1. So then so actually, if we come back here, 3/2. This is out of our range here. This 3/2. Because recall that the amplitude of sine is 1 and -1. And if we do 3/2, sine theta equals 3/2, then that means we're above 1. So we don't have a solution here. So we have no solution there. But for this here, because we're supposed to be on this interval, -1 to 1. Hopefully you guys recall this. We're supposed to be on the interval -1 to 1. And this would be above 1, so that's not going to work. And so for sine theta equals 1, note that that angle is actually 90 degrees, which is pi over 2. So then here, theta is pi over 2. Alrighty, so here we're asked to solve 2 sine squared theta plus sine theta equals 0. We don't even have to let x be anything here. You could simply look at this as a factoring problem. You have sine squared and sine here, so since sine is common to both terms, let me rewrite the problem. Since sine is common to both terms, we can just pull it out, right? Because if I pull out a sine here, I'm going to be left with a sine and then plus 1. So what this means is either sine theta equals 0 or 2 sine theta plus 1 equals 0. Of course, we solve these directly. Now, if sine theta is equal to 0, right? So that's looking at where we have our x values are 0. And so that means theta is going to be at 0 as well as pi, right? Because they're looking for your y values when y is 0. So y is 0 here and y is 0 here. And that's going to be 0 and pi. Hopefully you guys know your unit circle. Alrighty, so then now the other option here, so if we solve, we have 2 sine theta equals -1, and then we have sine theta equals -1/2. And so again, we think, what values of theta would give us -1/2 when we take the sine of it? Well, theta is going to be 7 pi over 6 as well as 11 pi over 6. So again, note that we are where? We're between 0 and 2 pi. All right, and so these are your solutions. Your solutions are going to be 0 pi, 7 pi over 6, and 11 pi over 6. Okay. All right, so now let's say we want to use the identities to solve some equations. So for instance, here we have cosine x, cosine 2x plus sine x sine 2x equals √3/2. And of course, we're solving in this interval between 0 and 2 pi. All right, so, and actually it's not theta, it's x in this case. All right, so let's see. Do we notice anything here? Hopefully we notice that this is the difference formula, right? Because recall, cosine alpha, cosine beta plus sine alpha. Well, this is going to be equal to cosine alpha minus beta. Using that, that means this side can condense to be cosine x minus 2x. And that's going to be equal to root 3 over 2. And so x minus 2x is going to give us negative x. And if you think about it, using the fact that cosine is an even function, this is the same thing as cosine x. Okay. All right, so now with that being said, we're trying to figure out what value of x will give us root 3 over 2. Well, again, thinking of a unit circle, only 2 x values give us this, and that will be pi over 6 and 11 pi over 6, and I'll use a correction, only 2 x values within 0 and 2 pi. So these are our solutions. All right, so the last example we're going to use is the double angle formula. And so they told us to use it anyways, so which is great. So we have that cosine of 2 theta. Cosine of 2 theta equals cosine theta, and so we're trying to solve this. Alrighty, so we know that we can rewrite cosine 2 theta as what? We can rewrite that as 2 cosine squared theta minus 1. This is our double angle formula. We're still going to have this cosine theta on the right-hand side. And so we can also rewrite 2 cosine squared. Actually, no. We could look at this as a quadratic because it's a squared, and this is also cosine. So we can bring everything over to one side. This becomes 2 cosine squared theta minus 1 minus cosine theta will give us 0 on this side. So if we let me rewrite this in standard form before I do that. So this becomes 2 cosine squared theta minus cosine theta minus 1 equals 0. So if we let x be cosine theta, then I have 2x squared minus x minus 1 equals 0. All right, so I'm looking for two numbers that multiplies to give me a negative 2 and adds to give me a negative 1. So that's going to be, if I rewrite this, that's going to be negative 2x plus 1. And so this is going to be minus 1. So it should be a 1x. Okay. I'll just say x. All right. What's common? So here we have a negative 2x. Oh, it shouldn't be negative. So just 2x is common. And then this gives me x minus 1. On this side, just 1. And still have x minus 1 equals 0. So we have 2x plus 1 times x minus 1 equals 0. Using the fact that we let x be cosine, we can rewrite this as 2 times cosine theta plus 1 times cosine theta minus 1 equals 0. So that means either 2 cosine theta plus 1 equals 0 or cosine theta minus 1 equals 0. So let me just make some space here. So if this is the case, alrighty, so if this is the case, so the first one we have 2 cosine theta plus 1 equals 0. So then we have 2 cosine theta equals negative 1, and so Cosine theta is -1/2. What theta gives us that? Well, that's going to be 2 pi over 3. And 4 pi over 3. Now, they didn't give us a restriction, so in this instance, that means we have to also account for other rotations. So that means theta is 2 pi over 3 plus 2k pi, as well as 4 pi over 3 plus 2k pi. Again, k is an integer. So that's only for the first one. So now for the second one, we have cosine of theta equals -1. So let me just snag that. Cosine of theta -1 equals 0. So that means cosine of theta equals 1. So we're thinking, what values give me cosine of theta equals 1? Well, that's going to be, cosine is my x value, so that's going to be 0 and 2 pi. But in this instance, so we're just going to say theta is going to be equal to 0 plus or minus 2k pi. And so 2 pi would be when k is 1, so you don't have to repeat it. Of course, k is an integer. And so these are my solutions. Now, of course, these problems vary, but with practice, you get better. All right, so we'll stop here for today. Be sure to do your homework. Have a good one.